Yo, yo. Alright, so we're going to cut the nozzle throat in this nozzle real quick. I machined it. I didn't cut a throat when I machined it, so we're going to go ahead and chuck it back up as it's already done. Just run a boring bar through it real quick and put a throat in. So I had to swap boring bars. The first one was too short to get down into the depth of that thing to cut this throat out. So I also repositioned. Hopefully you guys can have a little better of a view. I tried to get it so you could look down, the throat of the nozzle, but I'm just in the way while trying to machine it. So sorry, that didn't work out. So I think I stated before, this is a really quick and easy, straightforward process for me. I've had this all laid out in my notes, and I've done this countless times before. So like I said, this is only like maybe 10 minutes worth of work tops, just to blow a throat through this thing real quick and make sure it was to the correct tolerance that I was happy with, which it was. So yeah, that being said, you're about to see here in a moment, we're going to switch over to the injector donut and go from there. So I really love these Milwaukee gloves. They're freaking great. But trying to do small finesse work with them on can get a little tedious, and you can see me fumble this thing here for a minute, just trying to make sure I was correctly reading it. I didn't feel the need to mic it. I could have mic'd it, but this is plenty accurate. I mean, I check all my calipers on gauge blocks pretty regularly, and they do get sent out for cal typically once a year. But yep, we're good on the throat. Fixing to move on here in a minute. I don't know if you can tell, but it's hot as balls in this shop. I don't have foam shot in the roof yet, which I need to do. I just need to get some money to do it, to order the material so I can shoot isonine on this roof, so it's not a sweltering 104 degrees in here constant. So that's coming up soon. So we got that checked out. My goal was a 2.600 throat. I ended up with a 2.57 throat, and I'm good with that. Worked out. Gonna knock off the hard edges. I'm not putting a radius on this, I don't think. We'll see. If I do, I'll get out the radius gauges and we'll get a nice radius on it if I decide to. I gotta look at my notes, see if I ran one on the old one. I don't think I did. All I'm doing is knocking down that hard edge. And this is 400 grit. I don't know if I explained it or not. This is a phenolic ablative nozzle. It is for the R10,000. They're quite time consuming to make. Starts as square blocks. You gotta chuck up and round out those squares into circles, and then bore out your centers for your graphite core. Make sure you got a step in there so your core doesn't blow through. I can do a whole video on nozzle assembly on the next one. It's 3745, or excuse me, 4515. Yeah. 45, 15. I have done 37 degree on other hybrids. I've only ran them on smaller 54, 75, and 98 millimeter hybrids. I've done tons of nozzle R&D on smaller scale stuff. Doesn't always scale up how you'd anticipate it to into larger stuff. So on this R10,000, because it's such a high-end build, I stick with what I know works, and you know, go from there. So it's a 45 convergent, 15 divergent, phenolic ablative nozzle. I think I started with a 6-inch core. There's not much here to ablate, but there's much more here to ablate. Plus, you know, once the core is placed in here, I use a styrofoam core to pour around, and then I just melt it out after. It's the easiest way to do it. So, you know, it's covered in fuel from here out, so this doesn't even get exposed until the last probably 5 to 7 seconds of the burn duration, and then that's when this will start to all ablate. But there you have it. 1, 2, 3, bing bang boom, put a throat in it. Probably took less than 15 minutes. I also knew where I left off, picked up where I left off, and referenced back on my notes to where I wanted to be, so on and so forth. But yep, throat, R10,000 phenolic ablative nozzle, 1, 2, 3, done. So now we're doing the Injector nozzle donut, which is a phenolic spacer, which will get a graphite insert, and then that'll be pushed into the nozzle liner, which is over there, and then that will be machined out, and it'll sit up against this, and then the nozzle, fuel grain liner, nozzle, everything all in one shot gets pushed on, and the nozzle liner will sit here, and then you can get your lower fuel grain housing slid over it, and so on and so forth. It'll all make sense here shortly. I'm just gonna set this back here. So I'm actually taking like 1/2-inch plunges on this chunk of phenolic, because honestly it's hotter than heck in here, and I just want to get this part done. Phenolic's a mess. I try to keep the mess to a minimum. As you can see, I'm running a vacuum, and I'm usually always running a vacuum when I'm doing graphite or phenolic, just because it's extremely messy. But yeah, I'm just mowing through this phenolic, 1/2-inch plunges, just hogging it out, and I'll burn through it. I don't even think I videoed this whole section because, quite frankly, it's pretty boring. But I snapped some photos and so on and so forth, and I'll make sure I include them here at the end of this short little clip.
tell it's hot as balls in this bitch.
This is the fuel grain component overview, most of the parts. This is the radius gauge and high-speed steel I cut. Checking that radius. There's the phenolic fuel grain liner marked out for its donut. Now you got the liner, the housing, the donut, and the core. And that's it nested in place. And that's what I got for now. See you all in the next one.